Okay, today we're going to look at recording some probabilities, but instead of being just a regular probability question, we're going to look at questions that have tables. So they give you a table of information, and then we're also going to look at some that have some more complicated combinations that we want to use maybe a different way of solving these. So we'll go through the tables first. So this first example I got given to you shows males and females that either drive to school, so they take a car, or they take the bus, or they walk. Other would be walk or get a ride or whatever. So we have bus, car, and other. You can see in the table they all give those to you. So the first thing you want to do with any of these questions is, if they gave you a table question, is you want to figure out those totals. So I wrote in here all of our totals for each. So all of the kids that ride a bus were 650. All the ones that drive a car were 375. All the ones that did other was 175. And then we also want to total horizontally. So the total number of males is 625. Total number of females is 575. And if we add up all of the bus, car, and others, or if we add vertically the males and females, either way you should get a total of 1200. So your first step always is you want to get those totals. Once you have the totals, now the rest of the question is pretty straightforward when you look at the chart. So the first one I've got here on letter A is, what's the probability that if we picked one person at random, we would get a male? Well, we can see here our total number of males is 625. And our total number of people was 1,200. So we'd have 625 males out of the 1,200 total, and that would be our probability. You'd want to reduce that fraction or change it to a decimal or percent or whatever, but we won't bother wasting time doing that. We'll just look at the total fraction, and that's it. So the next question is a little bit different. So we see the slash, so C/M means what's the probability we have somebody that drives a car, given that we know that it's already a male. So what you want to do with this one is you want to be a little bit careful, because it's saying what's the probability it's a car if we already have known that it's a male. So what we're looking for then is just this whole top row. Right? We know it's a male, so we only have that top row. How many males drive a car? We have 200. So we'd have 200 out of the 625 total males. Okay, so those ones are a little bit tricky. You got to be careful when you see that slash. The next one, it says, what's the probability it's a male, given that we know it's a car? So now in this case, we want to use the other column. So we're looking at just the car column. We know it's a car, so how many males drive cars? We have 200. But now we have a total of 375 that take a car. Okay, so you can see those two are a little bit different. It's just depending on which column or which row you're looking at. And the last one is a little bit easier. It's saying, what's the probability that we have one person now that is a male and they drive a car? So now we're just looking at the intersection of the two rows. So it'd be 200 people out of the total. We still have 1,200. Right? Male and car is 200 out of all the whole group would be 1,200. Okay, so those ones are a little bit weird, but you got to be careful that you get the order and stuff figured out. Okay, the rest of these, like letter B now, is we're looking at the same thing, but they're just in words. So what's the probability to be a female? So you can see we have a total of 575 females out of the 1,200 total. Okay, the next one is, what's the probability that someone drives or rides the bus to school? So our total bus kids are 650 out of the 1,200. And what's the probability that it's a female and on the bus? So that would be 300 females are on a bus out of the 1,200. Okay, so whether it's in words or symbols, they both mean the same thing. And letter C now, same sort of thing, except it's a little bit trickier. So now we're saying, what is the probability we have a female that is on a bus? So it's a little bit different than B. Letter B was, how many females are also on a bus? Letter C is saying, how many females that we have that are already on a bus? We know out of just the bus kids, we're looking for the females. So that'd be 300 out of the bus kids are 650. Okay, and the next one, same kind of question. We know that it's a car driver, so we don't know how many car drivers are males. We just look at the car drivers and we want to know the males, so that'd be the 200 out of all the car drivers, which was 375. Okay, so just be careful with the wording. Sometimes it's a little bit confusing. So that's how you do these kind of questions. And the last one I got on here, letter D, it's a pretty easy one. It's just saying, is being a female and riding a bus independent? So one would think no, right? You can be a female and on a bus, but let's actually prove this using the formula. So our formula would be A and B would equal A times B. Okay, so if this was true, if it was independent, those two things would be the same. So what's the probability it's a female and a bus? We already did that in the question right beside. That was 300 out of 1,200. And then if we do probability of just being a female, that was our first one in letter A, so that was 575. And our letter B was a bus, so that was the 650. So the question is 575 out of 1,200 times 650 out of 1,200, is that equal to 300 out of 1,200? And if you do that on your calculator, the answer is no, those are not equal. And that one actually works out to, let me just see if I have the answer handy here, I think I do. The actual answer for that would be 299 out of 1152 if you reduce your fraction. So 300 out of 1,200 is not the same as 299 out of 1152, so we'd say no, they are not independent. And common sense would also give you that, right? We do have females that are on a bus, so that means that there was some sort of overlap that we'd have to take care of. Okay, so now we're going to look at doing some probabilities like we've seen before, and then we're also going to look at sort of a new way of doing this, and you can decide which way makes more sense to you. When you're solving these kind of questions, there's multiple different ways of doing them, and you can sort of pick and choose whatever makes it easier. So the question we're going to look at, or the example we're going to look at, is we're going to draw 2 cards out of a deck of 52. So we want any 2 cards from a regular deck of 52. So the first one is, what's the probability that we get a king and then another king? So we want 2 kings out of the 52. And we're going to assume that we're not replacing any of them, right? We're just going to pull one card out and then pull another card. So you're going to get dealt 2 kings. When we did this last week, we were looking at these kind of questions. We said there was 4 kings out of 52. Would be our first one. And then our next king would be 3 out of 51. Okay, so that's the way we did it before. The new method we're going to use is combinations, and in some cases these are easier. So in this case we're drawing 2 cards and we want them both to be kings. So using combinations, we'd say we'd use 4C2. We don't care about order, so C would be the right way to do it. And we're looking for any 2 cards out of the kings, so 2 out of the 4 kings. And then, so that would be our top number, and then on the bottom we put our total, and we're taking 2 cards out of 52. Okay, so if you do these 2 solutions, you will get the exact same answer. And you can figure them out on your calculator to actually prove that they're both the same. Okay, let's go through the next one. It's a little bit different. It's now we want a king first, and then we want to get a 5. So the king part would be the same, 4 out of 52. And then now a 5 would be, there's 4 5s out of 51. So that's how we do that using the old method. And to use combinations, we would do 1 out of the 4 kings, and then 1 out of the 4 5s, and we're still picking 2 out of 52. Okay, does order matter in this case? Yes, we want the king first and then a 5. So that means order does matter. So we have, okay, so because order matters, we actually messed up. Okay, so when we're doing this one, because we want a king and then a 5, order does matter. So what we should do is actually, instead of using the C, we actually needed to use a P. And that's what using this new method tends to cause things to be a little bit easier in some cases, because it takes care of whether there's order or not just by using the P and C. So for this one we should have used P's. We want a king and then a 5. So 1 out of 4, 1 out of 4 for the top, and then still 2 out of 52, because that order does matter. Now you can see for the next question it's the same thing. It says a king and 5 in any order. So in that case we would have the exact same question that I just had before I erased the P's to C's. So we'd have 1 out of the 4 kings, 1 out of the 4 fives, and then 52 cards. We were picking 2. Order doesn't matter, so then we'd use C. So you can see the difference between those two are similar, but order matters or not. This is the kind that would be a little bit careful. If order doesn't matter when we use the multiplication law, that means we'd actually have to do the question twice. You'd have a king and then a 5, and then we'd also have to do a 5 and then a king and add the 2 together. So we'd have 4 out of 52, 4 out of 51, and then we'd have to add 4 out of 52 and 4 out of 51 again. Or we could just take one answer and times it by 2, because we're basically taking a king and 5, or a king and 5 and king, which would be the exact same thing as just doing one answer times 2 factorial, because we have 2 different choices. So it sort of depends on the question. I would say for this one, the first method, like if the question was get a king and then a 5, it's probably easier to do the multiplication the way we did there. But if when order doesn't matter, then we're probably better off to use the C's. So it just sort of depends on the way the question's worded and which one you understand better. So the last one now, or the second last one, it says, what's the probability we don't get 2 kings? Okay, so in this case we would have, let's do the multiplication first. So we don't want a king, so that means there's 48 cards in the deck that aren't kings. And then we don't want another king, so it'd be 47 out of 51. And that would be it. So we'd see we get, those 2 would be our answers. Order doesn't matter, so we don't have to worry about doubling it or anything like that. And if we were to use the C notation, order doesn't matter, we want 2 out of the 48 cards that aren't kings. And our total would be 2 out of the 52. Okay, and now the last one is what's the chances we get at least 1 king? So that means we'd have 1 king and 1 other card, or 2 kings. So you'd have to do 2 different options. So this one's going to be tough in multiplying, so you'd have to do 1 king would be 4 out of 52, and then 1 other, so you'd have a king and then whatever else, so that would be 48 cards out of 51, and then we'd have to do 2 kings, so 4 out of 52 and 3 out of 51. Order doesn't matter, so that should be good. If we use the C notation to get at least 1 king, we'd have to do it sort of the same way. We'd have 1 king out of 48, or sorry, 1 king out of the 4, and then we'd have 1 other card out of the 48, or 2 kings out of the total. So 2 out of the 4 kings, all out of the total 52C5. Okay, so that would be the option there. Or the one other option, remember when in the last unit when we did at least, the other way you can do at least is do 100% minus the opposite. So at least 2 kings would be, the opposite would be having no kings out of 2 cards. So the other option is we could just do 100% minus the no kings, and the no kings we already figured out, right? We got those answers in the question ahead of it. So we could have done this one just by going 1 minus 48C2 over 52C2. So 100% is 1 as a decimal, and subtract the kings, we'd have no kings would be the answer that we had in the previous question. So that's another way you could do that one. Okay, let's do one more. So this one is similar kind of question again, except we have marbles. So we got marbles in a bucket or a hat or something, and we're going to reach in and pick them out. So let's suppose there's 6 blue and 10 yellows. So the first question is, how would we solve it if we get 2 blues in a row? So we'd have 6 blues out of 16, and then 5 blues out of 15. If we're to use multiplication, we're not going to replace. So just like before, we're not replacing. Order doesn't matter in this case, so 6 out of 15, 5 out of 15. Or If we use combinations, we want 2 out of the 6 blues out of 2 out of the 16 total. Okay, the next one is a blue and then a yellow, so order does matter. So we'd have 6 out of 16 for the blues, and then 10 out of 15 for the yellows. So that's easy if we do it that way. Or if we use the combinations, we'd have 1 blue, so 1 C6. We've got to be careful, order does matter in this case. Right, blue first, then yellow. So we want to use P notation. So 6P1, and then we want 1 yellow, so 10P1 out of 2 out of the 10. Where order matters, we'd use 10P2. Okay, and then our next one is similar again, except now we want blue and yellow, but order doesn't matter. So once again, if we just change it to C's, that's the easier way to go. So 6C2 and 6C1 and 10C1 over 10C2. So that would be if order doesn't matter. And then if we did it with the fractions, we'd have 6 out of 16 times 10 out of 15. Or, which means plus, we have to do the other order, so that we'd have to add it again. Or another way of doing it is just times it by 2 factorial, because we can flip the order around. So it'd be just that same answer doubled. Okay, let's do one more kind of question and then we'll stop. So this case we got 12 males and 10 females. And so they're in a classroom and the teacher's going to put people in groups. So the first question is, what's the probability we would get 1 male and 3 females in one group? So our group is going to consist of 1 male and 3 females. So order doesn't matter, so we want to use C's. And this is going to be the kind of question that would be pretty tough to multiply, because you'd have 1 male, so you'd have 12 out of 22. Then you'd have 10 out of 22. Let me just write that down to kind of show you. So 1 male would be 12 out of 22. Then a female would be 10 out of 21. Then another female would be 9 out of 20. And then another female would be 8 out of 19. But you can see here, that's a male and then 3 females in that order. But we could actually do a male, female, 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 or a female, male, or a male could go third, or a male could go last. We're actually going to have to times that by 4, because we have 4 different sort of orders that they could go into. So that's going to be the tougher way to solve it if you're going to try to multiply. So in this case, I think it's a lot easier to do the C notation. So the C notation is we want 1 out of 12 males and 3 out of 10 females, and our total would be 4 people out of the 22. Okay, so we'd write 22C4 on the bottom. So that answer should be the same as what I did above after you times it by 4. Okay, the next one I got on here is we want Ryan and 3 females. So in this case, instead of just being 1 out of the 12 males, it has to be Ryan. So you could write it as 1C1, because that would be Ryan, or you could just think of that as that's equal to just 1. So it would just be 1 times the 3 females out of 22 total. Okay, so the 1 Ryan isn't really going to do anything. It's just basically take him out, and then we just have 3 different females to pick from. And now the last one, we got Ryan and Susan. So we'd have 1 for Ryan, 1 for Susan, and then 2 other females. So we'd have 9C2. So the only trick to this is Susan is going to be one of the females, so we only have 9 left over to pick from after she is gone. And our bottom would still be 22C4. And that's it. We'll stop there. That's it for this topic, and that's it for this unit.